In question 3 here, we got a tennis club. There are 5 boys and 3 girls in the training squad. 2 are chosen at random to represent the club. Determine the probability that they are both boys, both girls, or a boy and a girl. So I've already set the tree up here where I've got the first student here and the second student here. And you can either have a boy or a girl at each step. So we notice that the total number that is available to be selected is 8. 5 boys and 3 girls. So at your first selection, what's your chance of taking a boy? We notice there are 5 boys out of a total of 8 students that can be selected. So your chance of getting a boy on the first pick is 5 out of 8, which means that your chance of getting a girl must be 3 out of 8. Okay, so imagine now we've chosen a boy and a boy's been picked out. What's the chance of choosing another boy? Well, the 5 boys originally has been reduced to 4. There's only 4 that could be selected from. So this will become 4 out of 7. And if a boy's already been chosen, there are still 3 girls that could be chosen from. So this would be 3 out of 7 for the girls. Alternatively, you could take a girl on your first choice, on your first selection. So then your chance of another girl would become 2 out of 7 because the first girl has already been taken out and she can't be selected again. So if a girl has been taken out, what's your chance of getting a boy? There are still 5 boys that could be chosen from. So this would become 5 out of 7. So we should also note again that these numbers reduce by 1, 7, 7, 7, 7. And we also see that the 5 reduces by 1 to 4. The 3 reduces by 1 to 2. And also this 5 is written here. And this 3 is written there. So this is one way that you can check that you've done it correctly. So we should write out the outcomes now. So we've 2 boys is possible. We could get a boy and a girl. We could get a girl and a boy. We could get a girl and another girl. So our probabilities then would be the product of our probabilities by the multiplication law. So this is going to be 20 out of 7/8 of 56. We could get 5 3s of 15 out of 56. 3 5s of 15 out of 56. And 3 2s of 6 out of 56. So you pick up your calculator, which is what I'm doing, and I'll simplify them. So 20 out of 56 is 5 out of 14. 15 out of 56 is 15 out of 36, which doesn't simplify. And so these are already simplified. And 6 out of 56 is 3 out of 28. So it's a good idea now to simplify your fractions at the last step here. So what's the probability we're going to get 2 boys? So 2 boys is already listed in our tree. So that's going to be 5 out of 14. 2 girls is already listed as 3 out of 28. So that's listed down here. 3 out of 28. So what's the chance? Oh, sorry, that should be here. 3 out of 28. I'm skipping. So what's the chance then of getting a boy and a girl? So boy and a girl can happen in 2 different ways. You could get a boy girl or you could get a girl boy. And then we add these probabilities. So you're going to get 15 out of 56 plus 15 out of 56, which is 30 out of 56, which will be 15 out of 28 as your final answer. So in question 4, Tara has 5 10-cent coins and 4 20-cent coins in her purse. She takes out 2 coins at random. What is the probability that she takes out at least 30 cents? So a minimum of 30 cents in total from the coins. So first thing to do, look at how many coins we have in total. 5 plus 4 is 9. So in the purse, there are 9 coins, 5 are 10 cents and 4 are 20 cents. So your chance of taking out a 10 cent on the first draw when you go in to take some money will be 5 out of 9. So that means that the chance of taking out 20 cents would only be 4 out of 9. So it's a bit less likely than the 10-cent coin. So if you've taken out a 10-cent coin, what's your chance of taking out another 10-cent coin? So that 5 is going to become 4 because one 10-cent has already been taken out. And there is one less coin. So that's going to be 4 out of 8. If you've taken out a 10-cent coin, what's your chance of taking out a 20-cent coin? Well, you've already taken out a 10-cent, but there are still 4 20-cent coins in the purse. So this will be 4 out of 8. Alternatively, you could take out a 20-cent coin at the start. What's your chance of another 20-cent coin? The 4 will become 3 because you've got one less 20-cent coin, and that would become 3 out of 8. So if you take out 20 cents, we still only have 8 coins, but we have 10 cents, which is 5. So that's going to be 5 out of 8 here. So that's your tree basically finished. And then we need to multiply to get your probabilities. But first we write the outcome. So your outcome here is 10 cents, 10 cents. So the total actually will be 20 cents, isn't it? The total here would be 20 plus 10, which is 30 cents. The total here would be 20 plus 10, which is 30 cents. And the total here would have been 40 cents. Because we need to recall that she was considering the total amount of money taken out. So these outcomes, I just wrote the total amount of money that could come out. And so your probability then of 20 cent total is 5 on 9 times 4 on 8. So that's 5 4s are 20 on 8 9s are 72. Then we've got 5 4s are 20. 8 9s are 72. Then we've got 5 4s are 20. 8 9s are 72. And 4 3s are 12. 12 out of 72. So what's the chance she would take out at least a minimum of 30 cents? So which ones had a minimum of 30 cents? This one, and this one. So all we need to do to get our final answer is to add these 3 probabilities here. So that will give us 20 plus 20 is 40, plus 12, 52 out of 72. And by simplification, so 52 divided by 72 will be 13 out of 18. So this is going to be your final answer. So it's a bit more than 50% chance that the total will be 30 cents or more.